welcome Dr. Feras. He will be speaking on an intelligent mobile skincare detection system. Hand over to you, sir.
Okay, thank you so much, Akib. Hi everyone, Assalamu alaikum wa rahmatullahi wa barakatuh. Good evening. I hope that you all are doing well and enjoying the time so far at the Saudi Mobile Show. I'll be introducing myself. My name is Feras Albardi. I am a recent graduate from King Abdulaziz University, where I majored in computers information systems. I'm interested in the research and development of intelligent systems that relate directly to healthcare and medicine. The main goal is to provide intelligent systems that are accurate, with high performance and low in cost to help people worldwide have a better healthcare experience. So today, inshallah, I'll be presenting my senior research project, which is titled an intelligent mobile skin cancer detection system. This system is able to detect skin cancer in skin moles images provided by end users. The system is also implemented on mobile devices, edge devices. So the way we will conduct this presentation is we will start with the introduction, then we will go to the problems that we want to solve. After that, we will go to the objectives of this research, and then methodology, results, and end with a Q&A. So let's start with an introduction. I'll be introducing AI for non-experienced individuals for convenience. So what is AI? AI is a major field of computer science. This field aims to the development of computerized systems that intelligently mimics the human mind's cognitive functions, such as learning how to solve a certain problem and make decisions when asked to do that. So we have about three major branches of AI. These measures are interrelated, so we use one with another. This is totally normal. The major branch of AI is considered to be machine learning. Machine learning is the processing of data to complete actions without being programmed to do so through analytical, mathematical, and statistical techniques. Under machine learning comes deep learning, which is a very popular field right now. After that comes computer vision, which is the field that I am most interested in. In computer vision, we use machine learning and deep learning to process and extract information from visual objects, such as images and videos. So this computer vision has many uses to analyze visual images and extract valuable information out of these images. Another major branch of AI is natural language processing, where we use machine learning and deep learning or deep learning to process natural language, which is the human language. Uh, uh, we process this data to understand, communicate, and manipulate as humans do. So I like this picture a lot because it represents machine learning as a field of its own, because machine learning and deep learning, because mostly all other branches depend a lot on machine learning and deep learning to be functional. So for example, we will use machine learning to analyze visual images. So that's for computer vision, and so on and so forth. Next, we will go to the uses and benefits of AI and machine learning. So AI and machine learning is being used in very wide areas. It's being utilized a lot in healthcare with medical diagnosis. It's also being used a lot in manufacturing with the detection of faulty samples and removing of these faulty samples, and in finance with the detection of fraud. So There are a lot other uses than just the ones mentioned here. Uh, AI and machine learning is being used right now and is popular right now for the benefit of reducing errors. So when we utilize an intelligent system to do some process, uh, we end up with lower error rates because humans over time may get low in performance. So, but machines don't. So that's why AI is being used right now for error reduction. It's also being used to minimize human risks. So instead of, let's say, asking for a human to do this risky tasks, we will ask this machine to do it. And it's really important uh, in this field. Another one is the automation of daily repetitive tasks. So a lot of us don't like doing a lot of repetitive tasks. So we ask machines to do it, which provides higher performance and more accuracy. Another use of AI is that it provides high performance and high availability. High availability means that it is available 24/7. So it doesn't require, yes, it does require maintenance, but not as humans do. Uh, so we will concentrate on the uses of AI and machine learning in healthcare, since this project uh, uh, is implemented in healthcare. Major use of AI in healthcare is with radiology. So in radiology, it is used to process and analyze radiological images such as X-rays, MRIs, and CT scans, and produce very high performance results that are compared to experts and better than some experts. Uh, Another use is for diagnosis of diseases. So we can analyze the patient's data, whether visual or not, and produce proper accurate diagnosis to reduce inaccurate diagnosis. Another use is for earlier predictions. So we will input data of some patients in the system, in some intelligent system. This system will process this data. Let's say, for example, the screening, diagnostic, and blood results of these patients. The systems can intelligently predict if this person will uh, 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 get infected with some disease or not upon his historical data. So we go to the problem that we want to solve. Um, we want to provide a solution for what? We want to provide a solution for the problem of skin cancer, not uh, because there are millions who suffer from skin cancer worldwide. Where it is considered one of the most common types of cancers. And as you know, for any type of cancers, early diagnosis means higher chances of cure. And getting proper diagnosis in our dails, in our daily lives is time consuming and very costly due to the large amount of patients in medical centers. And that's whether for government provided centers or private health centers. Since government provided medical centers are burdened with large number of patients, thousands of patients, it's really hard to get an appointment. And with private health centers, it's really expensive for us individuals with no insurance. So the objectives of this system is um, main objectives is to provide a system that is able to detect whether the user provided images of moles or lesions is cancerous, malignant, or not benign. So these two are medical names for cancers, malignant or not benign. We want to provide a system that is accurate and performant. We want to provide a system that is deployed on mobile devices, and we want to provide a system that is easy to use. So in this slide, you can see on the left image an example of a benign mole. So this is considered a non-cancerous mole. And on the right, we can see that we can see a malignant mole, which is a cancerous mole. There are some differences. Experts will differentiate between the two, uh, but for here we leave it to the machines. Methodology, how we created the system. There are three main phases that went the development of this system. First, which is a very important phase, to obtain the data, since AI and systems depend on data to train, to learn, to differentiate, and decision making. Uh, we obtained the popular HAM 10,000 dataset from Kaggle. This dataset is provided by the International Skin Imaging Collaboration. HAM 10,000 has 10,000 images of 7 different skin diseases, the popular 7 diseases, but we only need 2, and these are benign and malignant. Since our system concentrates on these 2, and after excluding all other classes, we end up with about 3,200 images, divided 1,600 for each class. After obtaining the data, and I want to note that this data is already processed, so it can be used directly for model development and training of the system. Phase 2 is where we develop the system. We use the popular TensorFlow machine learning library and deep learning library. It provides an easy to use and convenience for non-experts. Uh, we divided the data to 80% for training and 20% for validation, which is the default dividing technique for data. Unfortunately, we don't see a testing set because of the low volume of data. Um, we utilize some data augmentation techniques such as rotation, imaging crops, to increase the data for higher accuracy percentages. We found that it is best to train our model on a pre-trained model with transfer learning. So what this means is that we utilize a model that was already pre-trained on millions of other images, mostly the ImageNet dataset, uh, for the main purpose of the low volume of data. So if we, let's say if we want to uh, use this data with not a pre-trained model, we will get a very low results. So pre-trained models provide much higher results with lower volumes of data. The model that was already pre-trained that we selected is the VG60 model. It provided best results. We compared this model with ResNet's Inception, AlexNet, and we found that it provided best results. After completing the development of the model and testing this model with the images from outside the dataset, we then go to the model deployment. So the first step is to convert the trained model to a TensorFlow Lite format, because mobile devices cannot accept the uh, or it can accept the regular models, but it's much better to convert the model to a TensorFlow Lite format. It enables much better performance on mobile systems. We use TensorFlow's image classification demo application. This application is already provided by TensorFlow for research purposes, um, uh, where we integrated the light model with this application. So after deployment the model and testing it on new examples, we then go to the results. So the model provides very high accuracy with 90% of training accuracy and 86% of validation accuracy, which is considered high due to the low amount of data provided. So if we had much larger data sets, we will get much larger accuracy. It is possible to execute the model on mobile systems with the help of TensorFlow's demo application. So it provided an easy view and ease of use and convenience for researchers. Um, I want to note that this system is an example of the many possibilities of the use of AI and machine learning if integrated well with the medical field. So I will show results of the screenshot of the application working. On the left, you can see the application where it was directed to a benign mall. So this mall is available, is present on the body of my brother actually. So as you can see, it provided an 88% benign accuracy, which is correct. On the right image, it's a malignant mole. So unfortunately, I had to use an image for available online because I didn't have a person with malignant mole. So it also provided a very good result of 85%, which is great. So now I want to show you a video of the system while it's working. A minute, please. So we will start with the video on the right. This video represents a real-life classification example of the mole present on my brother's body. I will reply this. So this is the icon of the demo application provided by TensorFlow. When we execute the system, it works on real time. So it classifies images on real time. When we point the device to the mole present on the body, we can see that the system detects that it is benign, which is correct. Accuracy, of course, differs depending on the image that it received, because it classifies images in real time. We will see other video of the system operating. This is the main interface of the system, a very easy to use and convenient system, and intuitive to use. We can see here that the system accepts 224 images by 224, which is the same size of images that the model was trained on. So this system, when pointed to objects other than moles, so a benign mole or a malignant mole, we wanted to show you the behavior of the system. This is something to be solved, inshallah, later. As you can see, the system, when pointing to objects other than moles, it provides 99% malignant, especially malignant. This is, of course, wrong because the system is not possible to produce such a high accuracy. We will, inshallah, explore this issue more and try to solve it, inshallah, in the near future. So after showing the results, I want to give you a chance for a quick Q&A. If you have any question, please provide it to me and I'll try to answer it as best as I can. Please, if possible, write your questions on the chat if it's not possible to communicate with me directly.
Hello. If anybody have question, please feel free to unmute and ask the question directly.
I want to share with you the poster I wrote for this project. It was originally meant to present the project with the poster, but I found that it's best to use a presentation. So it seems that no one have any questions. So inshallah, I hope that you found this lecture interesting as I did. I encourage everyone to explore the world of AI and especially in the medical field because there are many possibilities available. So I think we have a question. Great. So I'll provide you my email for any questions or contact purposes. So yeah, I encourage you all to explore the world of AI. In the medical field, there are many uses for AI, many different uses, whether in security, in manufacturing, in education. I found it interesting to work with AI systems in the medical field because there are many issues that people suffer from worldwide. We can provide real valuable solutions to people and help them have better healthcare that is accurate and low in cost. Oh yeah, thank you so much for being here.
Hello. Thank you, Feras Albardi sir, for your valuable speech. Uh, have a nice evening and happy National Day.
Thank you so much.
Our
Goodbye.
next section will start at 8 o'clock. I have shared the link in the chat. Thank you,
Yeah.
everyone. Thank you for joining.